Alrighty. Hello, hello. Welcome to another lesson of Ohio 8th grade math test prep. Today we are talking about Ohio Standard 8.EE.1, which is having to do a lot with the laws of exponents and fun stuff like that. So we're going to go over all of the state test questions that have to do with that. Starting with this first one right here. Match the expression in each row of the table to its equivalent expression. So, to know our exponent rules, we have to know, to know how to answer this question, we need to know our exponent rules. Okay, so there are three exponent rules we need to know. We need to know the product rule. You know what? Let's use black ink for this today. There we go. So that we can see better. We need to know our product rule. Okay. Product rule is when you multiply numbers that have like bases. So x to the m times x to the n equals x to the m plus n. So in this case, you add your exponents. Okay. Then we have our quotient rule. Quotient rule is when you're dividing numbers with like bases that have exponents. So here we go, quotient rule. We have x to the m divided by x to the n is equal to x to the m minus n. So you think multiplication, you pair that with addition. When you think division, you pair that with subtraction. We also have the power rule. Okay, power rule. That's when you have a base with a power being raised to another power. X to the m raised to the n. And when you see this, what I always like to compare it to is I like to think of distribution. Because distribution is always multiplication. And here you're going to be doing the same thing. You're distributing this exponent in, so this will be x to the m times n. Okay? And then finally we have the negative exponent rule. The negative exponent rule. Because most times it will ask you to leave your answer with positive exponents only. So you have to know what to do if you have a negative exponent. That's x to the negative m. All you do is you take it and you move it to the other side of a fraction bar. So this will become 1 over x to the m. You move it to the other side of a fraction bar, and then you make it positive. Conversely, if you have 1 over... Ooh, that's a terrible line. If you have 1 over x to the negative m, you would move it to the other side of the fraction bar, and it would just become x to the m. What I like to do is I like to relate it to that one song from Madagascar. I like to move it. You have to move it. Okay? So, with all of that being said, we're going to look at this first problem. We have 5 raised to the 6th, also raised to the 3rd. So this becomes power rule right here. So we're going to distribute this 3 in here. So that's going to become 5 to the 6 times 3, which is equal to 5 to the 18, as 6 times 3 is 18. So you're going to check 5 to the 18. Then you have 5 to the 6 times 5 to the 3rd. This is now product rule. So in this case, you're going to add your exponents. So that's 5 to the 6 plus 3 equals 5 to the 9. Okay. So when you think of product rule, or even quotient rule, okay, you can think of it this way. When you have exponents are an example of what we call repeated multiplication. Okay, so if you have x to the 3rd, that's x times x times x. So it's 3 instances of x. Okay? And let's say I also have x to the second. That would be x times x, right? So now we're multiplying these together. So just for fun, let's get rid of the parentheses now. And what does that leave us with? X times x times x times x times x, which is x to the 5, which is why you add them. Okay? When you look at quotient rule, we'll do the same thing. X to the third is x times x times x divided by x to the second, which is x times x, right? So now you can start canceling out, right? Because anything divided by itself is equal to 1. So this x will cancel out, this x will cancel out, and that'll leave us with only x to the 1 by itself. And remember, if you're using any exponent rules, if you don't see a exponent next to a variable or next to a number, you always assume that variable to be 1. All right? So let's go to our second problem here. Select all the expressions that are equivalent to the following expression. So I see select all. Okay, so that tells me more than likely more than one right answer. Okay. There will be the very, very rare occasion, I think I've only seen it twice, where they'll give you a select all that has only one right answer. If I ever see select all, I'm just going to assume it is more than one right answer. Okay? So we have 2 to the third raised to the negative second times 2 to the fourth. So we're going to break this down one step at a time. First thing we want to do, we have to do this in order of operations, so we have to take care of our exponent first. Which is weird to say when everything has an exponent, but we have to take care of this distribution first. Okay? So we're going to distribute this in. 2 to the third raised to the negative 2, that's 2 to the 3 times negative 2, which is 2 to the negative 6, times 2 to the 4. So now I look, do I see 2 to the negative 6 times 2 to the 4 anywhere? I do. I see it right here. I'm going to check that as a correct answer. So then we do product rule, okay? 2 to the negative 6 times 2 to the 4, that would be 2 to the negative 6 plus 4. And when you're taking the state test, I'm always a big advocate for double check your math, especially when you have negative numbers involved. So I'll just do negative 6 plus 4. They give you the calculator. You might as well use it. That equals 2 to the negative 2. And I look, and I see, is that one of my answers? It sure is. It's right here. Okay, so now we have to use the negative exponent rule. 2 to the negative 2 becomes 1 over 2 to the second. Is that one of our answers? It sure is. And then if you wanted to go the extra step, you could go find out what 2 squared is. 2 squared is just 4 equals 1 over 4. That's not one of our answers, so we stick with where we're at. Okay? So let's go to our next question. Which expression is equivalent to 17 to the third times 17 to the 10th? Remember what the word equivalent means? It almost looks like it starts with the word equal. That's because it means equal. Which expression is equivalent? Okay? So this is product rule. So we know what product rule is. Product rule, we have x to the m times x to the n is x to the m plus n. We're going to add our exponents. So that would just be 17 to the 3 plus 10. We check and see if that's any of our answers. Oh, wow, look at that. What do you know? It's A. Done. Okay. So now we go to question number 4 here. Lena's work to calculate 25 to the negative 4 divided by 5 to the negative 2 raised to the second is shown. Okay, so let's take a look at how we can do this. Okay, let's look at step 1. Step 1, we're starting with what we have. Okay, so we go to step 2. Step 2, we appear to have split the 25 into 5 squared. That is a perfectly reasonable thing to do. Remember to use any of your exponent rules. They have to have like bases. I said that when I went over the rules. They have to have like bases. So what we're doing is we're manipulating and rewriting 25 as 5 squared, because 5 times 5 is 25. So that makes it so that our bases match. That is a perfectly legitimate thing you can do. Step 3. Well, it looks like we just took this 4 and we went in, and we're going to... So knowing this, we should be doing power rule, which means we should be multiplying our exponents. And we're subtracting here. So part A, an error in Lita's work first appears between what 2 steps? That would be between step 2 and step 3. What is the correct answer to the problem? All right, well, now let's work this out. 25 to the negative 4. Divided by 5 to the negative 2 raised to the second. So we're still going to follow her first step of splitting 25 into 5 squared, because we can do that to get our like bases. Okay? Over 5 to the negative second to the second. Now we have to do our distribution. We're going to do our distribution in the top first. 2 times negative 4 would give us 5 to the negative 8 over our distribution on the bottom. Negative 2 times 2 would be 5 to the negative 4. Okay. So, now we're left with quotient rule. In this case, we're going to subtract our exponents. So what I'm going to do is I'm going to very carefully type this in my calculator. Negative 8 minus parentheses negative 4. You always want to put the negative 4 like this in parentheses, because if you put minus negative, the calculator is going to get very upset at you. So you put that in. It gives you negative 4. So that's 5 to the negative 4. Then you want to put this back into a positive exponent. So we're going to move it with the negative exponent rule. 1 over 5 to the 4. And then we can find out what 5 to the 4 is. If you don't know how to use the exponent button on the calculator, you put in 5. You hit this button right here that looks like a little up arrow. Depending on what calculator you're using, it'll either put it into the exponent area like this, or it'll put just that up arrow. Either way is fine. Put in your exponent of 4 and hit enter. And you get 625. So the actual answer is 1 over 625. And that is your answer. All right. So, next problem. An equation is given where p and q represent integers. It says 3p times 3q equals 1 over 9. Okay. 3p times 3q equals 1 over 9. Okay. What are possible values of p and q? So, let's think about what we have to do to get here. Okay? First thing we have to do is we have to make this 9 into a 3, so it matches the base. How do we do that? Well, 9 is equal to 3 times 3, so 9 would therefore be equal to 3 squared. Whoops. Is that how you write that? 3 squared. So let's replace that now. 3q equals 1 over 3 squared. And then what you could do is you could use the negative exponent rule to get this out of the denominator. So 3p times 3q, what you're going to do is you're going to move it to the numerator and you're going to make the exponent negative. So 3 to the negative 2. So we know based on product rule that when you multiply numbers with like bases together, you add the exponents. So your combination of P and Q can be any combination of numbers that add up to negative 2. For example, you could have P is negative 3 and Q is 1. Or you could have P is negative 2 and Q is 0. Or you could have P is 4 and Q is negative 6. All of these end up working out to give you a final exponent of negative 2. You just need any combination of numbers that add up to negative 2. So for this example, I'll use P is negative 3 and Q is 1. And I'll call it a day there. All right. Next question. An expression is given. 3 to the second raised to the third times 3 to the sixth all over 3 to the fourth. Select all the expressions that are equivalent to the given expression. So we're going to do this the same way we did the previous problem. We're going to take it step by step and check off answers as we get there. So first step, just like last time, is distribution. We're going to multiply this 3 by 2 based on power rule. So 3 to the second raised to the third is 3 to the 2 times 3. 2 times 3 is 6. Times 3 to the 6 over 3 to the 4. Is that one of our answers? It's not. Okay. So now we do product rule, fixing our top. 3 to the 6 times 3 to the 6 is 3 to the 6 plus 6, which is 12, over 3 to the 4. Is that one of our answers? Sure is. And then finally, quotient rule. 3 to the 12 over 3 to the 4 is 3 to the 12 minus 4, which is 3 to the 8th. Is that one of our answers? It sure is. That's it. That is problem done. All right. So I believe our final question of this video, yes it is. What expression is equivalent to 5 to the second raised to the 4 times 5 to the 5? So again, we're going to do our product rule. Distribute in. 5 to the 2 raised to the 4 is 5 to the 2 times 4, which is 5 to the 8, times 5 to the 5. Product rule says that we add our exponents now. 5 to the 8 times 5 to the 5 is 5 to the 13, which is choice B. Okay. So that's your review on exponent rules. I hope it was helpful. I'll be back for one of our other standards, and I hope to see you then.